Traveler-1, NASA's farthest voyaging rocket, continues with its astounding undertaking through space, immaculately conferring gigantic information from the most significant districts of the universe. For almost 50 years, this uncommon space test has changed how we interpret space. However, the space gadget has been passing disturbing information back to Earth, leaving the entire space industry in shock. Are these disturbing signs the result of a technical breakdown, or the activities of extraterrestrials? Join us as we uncover the truth behind these stunning transmissions. Since the beginning of history, researchers have been charmed by the insider realities that lie beyond our eminent limits. This premium incited the imminent launch of the Explorer-1 and Explorer-2 space apparatus, among other exceptional space missions. These momentous missions, which had been analyzed for a significant length of time, began with the launch of Explorer-2 from NASA's Kennedy Space Center on August 21, 1977. 14 days later, on September 5th of that very year, Explorer-1 followed suit. These twin tests, each weighing a basic 720 kilograms, equivalent to a small vehicle, were driven into space during an exceptional alignment of the outer planets. Throughout their astounding odyssey, these daring excursions explored various directions and speeds, leading to an essential moment on December 15, 1977, when Explorer-1 beat its unnamed twin due to variations in their paths. Since then, Explorer-1 has become a tremendous asset, providing us with a wealth of information and opening space-related insights. Before we dive into Explorer-1's astounding new discoveries that stun the whole space industry, let's examine the phenomenal pictures caught by the rocket during its critical Jovian imaging mission in 1978. Explorer-1 was positioned around 265 million kilometers from Earth, and from this vantage point, it sent back an astounding number of photos. In January 1979, it embarked on a special 100-hour endeavor to capture an entrancing time-lapse film showing 10 rotations of Jupiter. A cornucopia of 3,750 images permitted us to observe Jupiter's wonderful dance in particular detail. In the following months, Explorer-1 wandered through the Jovian moon system, making a striking revelation: the presence of a small ring surrounding Jupiter and 2 new moons, which further expanded our understanding of Jupiter's enrapturing region. To ensure safe entry and prevent a potential contact with Titan, one of Saturn's moons, remedial maneuvers were executed. Explorer-1 continued its heavenly endeavor around Saturn, uncovering 4 additional moons: Mimas, Enceladus, Tethys, and Rhea. With the peak of the Saturn mission, researchers chose to close the Explorer planetary mission, pushing both Explorer-1 and Explorer-2 beyond the limits of our planetary system, speeding through space at an astounding speed of 325 million kilometers each year. In January 1990, another chapter began, the Explorer interstellar mission. During this stage, Explorer-1 conveyed some of the most famous photos in history, deifying the Sun and most of the planets. One person who played a critical role in extending the missions beyond their initial objectives was the prestigious cosmologist Dr. Vasil Sands. As part of the Explorer mission's imaging group, Dr. Sands passionately advocated for capturing one last series of pictures as a farewell gift to humankind. His unflinching determination proved successful on February 14, 1990, when Explorer-1, positioned 6 billion kilometers from the Sun, embarked on a visual excursion known as the Planetary Family Portrait. These remarkable pictures, totaling 60, added to the space apparatus' impressive collection of 67 photos. During its encounter with Neptune, Explorer-2 achieved a striking accomplishment by recording wind speeds exceeding 13,100 meters per second, making it the fastest wind ever recorded in our solar system. As the space apparatus wandered within 280 million kilometers of Neptune's blue methane atmosphere, it provided us with rare insights into this distant celestial body. Notably, Neptune's largest moon, Triton, was revealed to be perhaps one of the coldest bodies in our solar system, with surface temperatures plunging to a frigid -391 degrees Fahrenheit. Triton's unique features, such as its nitrogen gas geysers that erupted frozen particles 5 miles into its thin atmosphere, also captivated our imagination. These unprecedented revelations extended our curiosity about the vast variety and complexity of celestial objects residing in the farthest reaches of our solar system. Don't go anywhere. The Explorer 1 space apparatus has recently made perhaps its most unnerving discovery. However, before we investigate what it has achieved in the past 45 years, we must first consider its many astounding accomplishments. The achievements of the Explorer twin space apparatus have been truly remarkable. Over 40 years ago, their initial observations of Jupiter and Saturn's moons left scientists in awe and shattered previous assumptions about these worlds. These moons, once believed to be dormant and heavily scarred like our own moon, turned out to be teeming with geological activity. Explorer 2, in particular, achieved several significant milestones during its journey. It made history in 1986 by becoming the first space apparatus to fly by Uranus. Just 3 years later, it accomplished another remarkable feat with a flyby of Neptune. To this day, it remains the only space apparatus to have traveled such a path. As the Explorer space apparatus continued their journey, NASA implemented various measures to extend their operational lifespan over the years. Non-essential parts and radiators were deactivated to conserve energy, ensuring that these bold pioneers could continue their mission well into the next decade. Their estimated mission end date is set for 2030. For the scientists and specialists who have been involved in this extraordinary venture from the beginning, the peak of the Explorer missions is both a moment of pride and a bittersweet farewell. Their relentless commitment and passionate efforts have far surpassed initial expectations. The wealth of information returned by the explorers has provided invaluable insights, spurred numerous scientific discoveries, and ignited the imagination of countless researchers and space enthusiasts. Explorer 1 and Explorer 2 were no ordinary space tests. They were meticulously designed as consistent platforms with a rotation rate more than 12 times slower than the second hand of a clock. This design choice minimized visual blurring as the space apparatus captured images and data while traversing the infinity of space. Indeed, even before their encounters with the outer planets, their exceptional imaging capabilities began to astound scientists and the public alike. The space apparatus started transmitting images of Jupiter before reaching the gas giant. These early images, showcasing the swirling clouds and the famous Great Red Spot, thrilled crowds at NASA's Jet Propulsion Laboratory. However, it was the discovery of active volcanoes on Jupiter's moon Io that truly captured everyone's attention. Io, slightly larger than Earth's moon, turned out to be the most volcanically active body in our solar system. The space apparatus instruments detected clear signs from Io, which were confirmed by the detailed images they captured, revealing towering volcanic plumes and a surface scarred by volcanic eruptions. One of Io's most prominent volcanoes erupted with a force more than 100 times greater than Mount St. Helens, covering an area roughly the size of France. While the space apparatus cameras were eventually shut down to conserve energy and memory before their journey into interstellar space, it's important to note that the images they captured did not include Mercury and Mars due to various factors. In addition to Explorer 1 and Explorer 2's interstellar tests, NASA has also operated other prominent space apparatus, like Pioneer 10, Voyager 11, and New Horizons. Explorer 1 passed Voyager 10 on February 17, 1998, marking the moment when Voyager 10 became the most distant space object ever launched by humanity. Explorer 1 itself continued its solitary journey for an additional 14 years before finally entering interstellar space on August 25, 2012. However, no other space tests were nearby to observe. NASA did not publicly report this extraordinary achievement until 2013. What strategies ensured the success of the Voyager missions? One key strategy stood out as particularly brilliant: gravity assist maneuvers. These maneuvers played a crucial role in propelling Explorer 1 and Explorer 2 on their ambitious mission to explore the outer regions of our solar system. To reach these distant targets and gather vital data, the space apparatus required more than just their own propulsion systems. They needed a boost, and gravity assist provided precisely that. Imagine the two Explorer space apparatus, Explorer 1 and Voyager, embarking on their glorious tour of the solar system. Instead of relying solely on their engines, they participated in a cosmic dance with some of our neighboring planets. These heavyweight planets formed gravitational slingshots that propelled the space apparatus on their way. This strategy allowed them to conserve valuable fuel and gain the necessary speed to visit multiple targets. The principle behind a gravity assist, also known as a gravitational slingshot, is to transfer some of a planet's momentum to the space apparatus as it passes by. Picture Explorer 1 approaching Jupiter, a massive gas giant with a corresponding gravitational pull. With precise timing, Explorer 1 passed by Jupiter at just the right point and speed. Jupiter's gravity pulled at the space apparatus, accelerating it to a higher velocity and providing a significant boost. Performing a gravity assist maneuver requires extraordinary precision. Had Explorer 1 approached Jupiter at the wrong angle or speed, the slingshot could have caused a catastrophic deviation from its intended course. The splendid execution of these gravity assist maneuvers enabled Explorer 1 and Explorer 2 to gather unprecedented data and images, significantly enhancing our understanding of the solar system. This method not only maximized their travel efficiency, but also allowed them to explore distant worlds that would have otherwise been unreachable. As the missions progressed, the findings from both Explorer 1 and Explorer 2 opened new frontiers in planetary science. The detailed images and data collected from Jupiter, Saturn, and their moons provided insights into their atmospheres, compositions, and geologies. Discoveries like the active volcanism on Io and the intricate ring systems of Saturn reshaped our understanding of celestial mechanics and the dynamic processes at play in our solar system. Additionally, the missions inspired a generation of scientists and engineers. The technological innovations developed for the Explorer missions laid the groundwork for future space exploration endeavors. The legacy of these missions extends beyond the data returned. They sparked public interest in space and fostered international collaborations that continue to this day. As we look back at the contributions of Explorer 1 and Explorer 2, it's clear that their journeys were not just about reaching distant planets, but also about expanding human knowledge and igniting curiosity. Their discoveries have been vital in shaping our understanding of the universe and our place within it. Now, as Explorer 1 continues its interstellar journey, it represents more than just a spacecraft. It symbolizes human ingenuity, the spirit of exploration, and the relentless quest for knowledge. The missions have taught us invaluable lessons about the cosmos and have paved the way for future explorers to build upon. In conclusion, the legacy of Explorer 1 and Explorer 2 will endure, reminding us that while we have made significant strides in our understanding of space, much remains to be discovered. As we continue to probe the depths of the universe, we honor the pioneering spirit of these missions and the countless individuals who contributed to their success.